First, it would probably help if I unmuted my microphone so that you could actually hear me. Good evening, I'm Justin Morgan, also known as Classically Schooled on Twitch, and I am building an Adafruit x0xb0x box tonight. I am still working out some streaming issues. I think I've got the audio situation under control. So now I am working on trying to find a light so that I can better illuminate what I'm working on, but that does not cause unintended glare issues elsewhere. Mainly glare on the webcam pointed at me that causes complications. If you just imagine the light that you see above me there, and imagine it was even closer to the camera, those type of complications, or they're just so bright that it washes out the image. Oh, I just realized the reason why the image was upside down is because I have the board upside down, but that's fine. You'll be able to see the board the way it goes in the, and no, that's not going to be very helpful. I'm sure at some point I will regret having the, no, actually, that is probably the better view for you all, I just realized, because this is the area where we will be, oh, hold on. Yes, it would probably help if I had the board situated correctly. So now, let's try that. And there we go. So this is the area of the board we will be working on first. So as long as you can see that, then we are good for now. If we get done with this part of the board, I will pull the other board out because I am doing this build in the order of the build directions, which I printed out because my safety glasses will start fogging once I put them on, which will make reading computer screens difficult. So to be nice to me, so I can actually read the instructions, I printed them out. So in the build, there are several different, and the soldering iron is off. So don't worry about me using it as a pointer. It is definitely off. So in the build instructions, Adafruit, or actually in this case, possibly Lady Ada herself, because I think she's the one that designed this, she broke the build up into logical steps so that as you complete each section of the build, you can test it. So the first build section is the power. So we are going to start with the power section of the x0xb0x box, because once we build that, we can use a voltmeter to confirm that we have the appropriate voltage rails. Plus, it's good to have that working before you go on to the next step, which is the voltage controlled oscillator. And we may actually get to the point where we'll start to build that. I doubt we'll finish that tonight. Then we've got the voltage controlled frequency, I believe, the envelope generator, the voltage controlled amplifier, although that doesn't seem right. Then the headphone circuit, the I/O board, which I think the power's on the I/O board, but I think that's the MIDI ports, the sequencer part of it, and then there's some finishing steps. So we are going to follow these in order because with a build this big, it will be good to do it in steps where we can test. Tonight, I will be... I was on the fence, but tonight I will be, once again, using lead-free solder. I am thinking that if I use flux, that I will not have any trouble, and as long as I also do not change the temperature of the soldering iron much beyond the solder manufacturer's recommended temperature, then hopefully I will be fine tonight. Because if you saw my stream yesterday, you would know I destroyed a PCB soldering. I have temporarily pulled that video down because I am going to go into YouTube Studio and add some text captions as warnings to point out where I started to make mistakes, and then I'll put the video back up because it's probably good to learn. But I believe my mistakes were that I followed the solder manufacturer's directions where they said don't use flux, and I believe that was probably wrong. I should have probably used flux. Even though this is rosin core solder, I probably should have used flux. That would have probably helped my flow issue. I'm sure this flux here would be fine. It's just some no clean, lead-free flux. The other thing that I did wrong, which probably did not help, is I increased the soldering iron's temperature because I thought it was not getting hot enough, so the solder wasn't flowing, and I just jumped it 100 degrees. And that was probably a very wrong mistake. And I can't also exclude the possibility that there was a flaw in the PCB, because quite honestly, I didn't think I held the soldering iron long enough to actually burn a small hole into it. But there is definitely a crater where the pad was. So it is quite possible there was a void in the PCB, or maybe I did really burn a hole in the PCB. And there's something funky with the pin I was trying to solder, almost like it melted, which is really weird. So I don't know what's up with that. But anyways, I should have not gone up 100 degrees. I should have stepped it much more slowly. At least I did think to stop when I started destroying the board. Although I don't know that I'll be able to repair the board. I might be able to. I'll need to get the correct wire, but it's an open source project, so I ordered some PCBs. And I'll probably just order the components I'd already soldered on it, and including a new IC socket, because there's something funky with the IC socket I was soldering. All right, now the first thing I need to do, because in live stream fashion, I just didn't have a chance to do everything I needed to do beforehand. I am going to pull out the parts for the power supply. I have a great big box of parts below me, and I'm hoping that I can more or less find them fairly quickly. Although while I'm pulling things out, I will I have this label I found on eBay that goes on the top. So I thought it's pretty cool. I realize you can't see the whole thing, but kind of the really cool. I don't know who did the label. That's the thing. It's not the Adafruit. It's not the Adafruit part, because Adafruit did sell this as a kit. I actually have what Adafruit sold with the kit in this box. Yeah, a big box of parts. Some of the parts I have are sitting on the desk because they were with the PCBs, and I am just really quickly going through the box to locate the... There's a few parts that I know go with this, and I am just going to really quickly locate them. I think they're somewhere on top because I have this distinct recollection of borrowing a few parts. And by distinct recollection, I mean I noticed that I have some handwritten notes on a couple of the bags that have parts that this project needs, where I wrote negative numbers on them, and some of the bags are empty. So I can only think that I borrowed the parts, and then I'm hopefully not going to find that the parts I borrowed were for this part of the build. Yeah, I'm basically looking for some of the large capacitors that I know are used in the power supply. I don't so much need the... A lot of these parts are mechanical parts. All right, so that is our... I've got our 9-volt AC transformer, because this takes 9 volts in and then creates the voltage rails from that. And do feel free if you have any questions. If I say something that you're curious about, feel free to ask questions. I don't mind answering them. I don't think there's anything, no such thing as a stupid question. So even if you think it's a dumb question or an obvious question, do ask it, because there might be someone else thinking the same exact question and they're too afraid to ask. So, because first of all, I find electronic builds interesting, but maybe you might learn something from it. Who knows? Now, the one thing I will say, this Adafruit no longer sells the kits, because this kit uses a lot of components that are discontinued and have been discontinued for quite a while. But I did manage to obtain most of the parts that were really critical. Some of them I bought off eBay. I've got this cute little bag here that is a lot I bought off eBay, and it actually has what I'm hoping is a pre-programmed microcontroller, even though I bought the microcontroller because this uses like a Atmega 168, so nothing terribly special. But I'm hoping this kit actually has... I'm hoping the one in this bag is pre-programmed. But the eBay seller had located some of the rare parts that have been out of production so long that usually the ones you find have actually been removed from another device, which is fine if they work. So some of the parts are just like common parts, so there was no problem finding them. Some of the parts were rare. I got some off eBay. I bought some from UT Source, and I think UT Source is the only, because I'd bought some chips from them for something else, and they were okay, so I used UT Source. I didn't try any other like chip procurement site, because quite honestly, I'd rather and I've heard good things about UT Source since, so I probably made a wise decision of buying it from them. If you're wondering, I had to buy some memory chips for an MSX computer, and I bought those off of UT Source. You know, it would probably help if I actually looked at the parts list to know exactly what I'm looking for. And maybe I've pulled enough out of the bag, I should probably just check the parts list real quick. There's probably some passives that... Yep, that's... Oh, wait a minute. I just realized. As I was saying that, I was tossing something back in the box that I believe is part of the power supply kit. And I almost looked over it because it's op amps. And op amps normally aren't used the way that this kit uses them. But when Lady Ada designed the zocks box, she built it pretty faithful to the Roland TB-303, which also used op amps as one of the to generate one of the power supply rails, because that's what gives it its sound. The chip can't supply enough power, so the sound is distorted because the chip is unable to supply the correct amount of power. And I think those are the op amps that are in the circuit. Anyways, as I was saying, I bought this label off eBay sometime earlier this year. It looks really nice, but this is what you would have received if you bought the kit from Adafruit. It's an aluminum plate, which is actually fairly nice. But I think there were a number of people that designed aftermarket labels that go on it. And quite honestly, some of them are designed for some of the aftermarket microcontroller upgrades, but it does appear as if the one I found is for the Adafruit microcontroller. Usually you can tell if it's one of the aftermarket ones because the legends on this encoder wheel some of them are different for the extra functionality, but it does appear as if bootload CB pattern edit. Okay, maybe there is I do see a slight difference. And maybe this is for one of the aftermarket ones, but because it says pattern edit here, but on the Adafruit original, it's user A. So, but that's actually not necessarily a bad thing. I was actually tempted to load one of the third-party microcontroller on this because some of them add some really cool features. Because Lady Ada went for a fairly authentic Roland TB-303 experience, but some of the aftermarket, or well, I guess aftermarket's the wrong term because this was she made this an open source project. So aftermarket's the wrong term, but I guess third-party improved microcontrollers add extra features. So, and I would try to remember what some of those are, but I'm sure I would get it wrong and then feel really bad. So I'm not going to try to remember them. It is quite possible some of the parts I need are in this package, or this box here. All right, so let's see what parts I'm looking for, and we'll see if I found them all. So first up on the list is a 9-volt AC transformer. And if you do build one of these, because there are some other places that I believe sell PCBs for zocks boxes. So you can't get them from Adafruit, but you can get them from elsewhere. So the note says you need to make sure it's 9-volt AC and 300 to 500 milliamps. So this should be more than good enough because this is actually a 1.11 amp transformer. So it has additional rating, which should be fine. So we'll need that when we get to testing. All right, there is a heat sink for the linear regulator. So this is just a standard. And if I have them in a bag that has a part number, I'll just show them real quick so you can see what part I bought. And in case you're wondering why in the world I marked this as the stream has promotions, it's because of my affiliate links down in the YouTube description. I actually bought all these parts for this, so Mouser is not a sponsor. They just happen to be the vendor I bought these from because they had a lot of the components that are still made. So, but this is just a standard TO220 heatsink, much like the one that Adafruit would have included. There is a barrel jack for plugging in the transformer, probably, and some of these parts I bought extras of, but just a standard barrel jack. And I actually have an extra, so I'm going to set the extra to the side. And I'll double check. So the transformer should just plug right into it. Yep. Fits nicely. All right. All right. Let's see. A 1N4001 diode. I'm going to double check the parts I had beside me because no, those are capacitors and resistors. All right, so I need diodes, which actually you're probably thinking, oh no, you're going to have to go through the whole box. But actually, knowing that I bought them from Mouser, it simplifies things a little because Mouser probably put the diodes okay, I think I actually did order the same part number because those diodes are still made. Anyways, Mouser usually sends diodes in the anti-static bag, so I don't have to go through all the bags in this box. I just have to look for the anti-static bags. Oh, wait. That's another one of the voltage regulators. Now, it's not always the case, but is usually. Oh, those are shift registers. And that's the microcontroller. Definitely don't need that yet. That is an in-channel JFET. That's not it. Those are LEDs. Those are analog switch ICs. I don't think those are transistors. Those are more transistors. There is a reason why, if you look at the Zoxbox website, it does have a comment of transistorize the world, because there's a ton of transistors on this board. That is not it. That's an EEPROM. Now, of course, there is the slight chance that no, I don't think it's in there. Oh, that's really weird. Okay, I may need to go check the shelf behind me because it looks like the diodes I'm looking for are not in that box. I mean, I found diodes, but they're not the same part number. It is possible they are compatible, but I think I've got a box on that shelf that says on it that it may have parts for the Zocks box. So I guess I will go. Oh, well, I guess let me double check that I didn't stick the. Oh, those are transistors. More transistors. Ah, that's the BA6110. And these are more transistors. That's okay. Yeah, I did not order. Okay, let me go walk over to the shelf. Actually, the one other box I'm thinking of may actually be upstairs. All right, but I did notice that this box has some parts in it. So I am looking for 1N4001 diodes. Yes, actually, those other diodes I found actually are used in this. I just realized they're the next item. So these are 1N4148 diodes, but I'm looking for 1N4001 diodes. I believe they are different enough that I need to find them. However, the 1N4001s are a pretty generic diode, so it is quite possible that those did get misfiled in a box somewhere. Oh, we'll have cool with that. It's a strip of neopixels. We'll have fun with that someday, but not tonight. I should probably hold on to. I think most of these parts are actually used for a different synthesizer. I had to replace some capacitors on one, although. Oh, yeah, okay. I don't think the diodes I'm looking for would be in here. Yes, I've got some Yamaha FB01 synthesizers, and that's what these parts are for recapping. All right, I am going to walk upstairs and go see if I can't find the box that said on it that it was that it had Zocks box parts in it. So I will be right back. So stay tuned. All right. I am not sure what I did with the box that said may have zocks box parts in it. But there was this box that was sitting on the shelf that has parts for another synthesizer in it. And I seemingly remember ordering some parts about the same time, so I'm just double checking. What is in here, because it's quite possible that the diodes are in here. No, that is not the case. There's actually an ARM microcontroller in there. And those are, it's an in-synth kit. And I'm not surface mount soldering tonight. In fact, I'll quite possibly might reflow. I may reflow these parts. Okay. I don't think the diodes I'm looking for are in there, which must mean that either there is a box upstairs that I overlooked that does say may contain zocks box parts, or I overlooked them in this box here. Okay, well, it might be in that bag, because that's the bag of stuff I had to order from DigiKey. It's possible that I ordered the diodes from DigiKey if I realized I'd forgotten to order them and hadn't placed the DigiKey order yet. All right, those are shift registers. These are okay. I don't think the diodes came from UT source. All right, the other possibility is it's possible those diodes are not in an anti-static bag. It's possible that maybe they're not. They didn't meet the static sensitivity. Also possible I swiped the diodes out of this box and then misplaced them. That would seemingly be how this week would be appropriate for this week, seemingly, that I would have misplaced a crucial part for the power supply circuit. Yes, logic would probably dictate that I start to set these parts out, but I don't have enough room on the table to set them all out on the table, and I really don't want to put them on the floor. Then I'd have to pick them up off the floor. Oh. You know, it did dawn on me that maybe I should check the bags that I had beside me. Just to make sure one of the empty ones doesn't say diodes. Oh, that was a resonator. A thin film resistor. Ah, electrolytic capacitors. I sure hope I don't need those. 16 volts, 2200 microfarads. Okay, now that's an ominous empty bag. Resistors. Okay. And this box had... Oh, more transistors. All right. Let's check this DigiKey bag here. See, those are potentiometers, potentiometer. These are the switches for these, or the buttons for the switches. Those are the switches. That is a trimmer. And that is a trimmer. Which actually... $2K trim potentiometer. Oh, okay. Let's see. That's actually one of the parts I needed. All right, I am going to drive on and come back. I will have to come back for the diodes. I'll have to figure out what I did with them. All right, so we've got our... Let me put this where you can see the parts list. Okay, so I don't know what I did with those. They are probably in... I've got a box that's sitting over there that the diodes may be in, because those are generic diodes. I may very well have those somewhere in a generic box. Okay, so I've got the 1N4148s. All right, so 100 ohm resistors. Because actually the other thing is, because I actually have a second PCB, and because the parts I bought off eBay had a PCB with them, I had trouble with the soldering the serial chip on it. So I do remember taking some of these parts. I think that's why there's parts missing in some of these bags, because I built enough of the power supply circuit to power up that serial chip. So it's quite possible the diodes never made it back in my box, because I think those are the rectifying diodes. All right, so I'm looking for the 100 ohm resistors. Actually, oh, I don't have... I was about to say, if I had a spare box down here, but I don't. All right. Oh, I guess. Let me take some of these big items out. So there's the case. Interestingly enough, some of these parts are... I've sorted through these before. There was all the resistors seem to be together in the box, so this probably won't take long to find them, because there they are. So those are there's the 100 ohm resistors. Yeah, let's see, 1K resistor, 1.8K, let me see, 4.7, Okay, that's not used in this. Okay, so let's see, those 4.7K are not used here. See, are the 10K ohm? No, I don't think the 10K ohm are. The 430 ohm. No, I don't think that is. 470 ohm. No. All right. Oh. Okay, so that's 100 ohm. $22K ohm is used somewhere else. I think next time I go to the everybody's favorite home improvement store, unless your favorite home improvement store is the other one, I should probably grab a few more of the plastic bins that I like to put components in. They're not anti-static bins, but I always make sure to put the parts. I don't put the parts directly in the bin. I keep them in the bags. But it might behoove me to grab a couple of them so I can at least have a bin for capacitors and a bin for resistors, and probably more than one bin for transistors. There's so many transistors in this project. Oh, 27 ohm. That is a trimmer. 150 ohm. Nope, not looking for 150 ohm. Audio potentiometers. More potentiometers. Okay, well, there's the 1.8K. So I think I'm close to where all the resistors are in the box. $200K. Nope, that's not used here. Okay, there's the 2.2K. Okay. So there's the, all right, so there's the 1K ohm ones. And the 1.8K ohm ones are right there. And the 2.2K ohm ones are right there. Now we got 6.8K somewhere. Let me hold on to that because I think I want to find that one is next on the list, 6.8K ohm. And I ordered one of them. Must mean that is the only one used in the project. And it is kind of an odd size, which is probably why I only ordered one of them. Okay, and then 2.4K ohm here. And I did, for some of these parts, even though the project says to use a that's 5%. I think for a lot of times, I just ordered 1% because it was parts of the project where it didn't really matter if it was a little more accurate because it's in, say, the power supply. And normally you wouldn't need a 1%, but given the pricing of resistors at the time I placed the order, it was cheaper to buy a 1% than it was to buy the 5%. Just because of weirdness in component pricing. Now, it's quite possible that if I was buying them in volume, it is quite possible the 5% ones would have won on pricing, but when buying the small number I needed for this project, because in a lot of cases some of these are just odd, and by odd resistor sizes I mean they're not your standard resistors, because there's sizes that are your standard sizes, and some of these are not the standard ones. So I didn't order a lot of them because the chance I would use them in another project was lessened. So in that case, that's why I would buy I was just buying the 1% because they happen to be cheaper in a small quantity. Because I didn't need to buy a whole reel of them. So there are times when you don't need the accuracy and you'll buy the 5%, you'll be fine. But obviously the 1% will be fine. So I guess technically there'll be some deviation from the Roland design, but honestly, some of the other things that I'll have done will probably also change the characteristics somewhat, so I'll probably not really notice. Oh, those are the PTC sensors. You know, I'm gonna set that this side. I've got this inkling that might actually be used on the power supply. Or one of them. Oh, that's close. I found another pile of resistors in the box. Our round resist up. That's for. I'm not even sure that's for this project. Ah. Oh, that's right. I was about to say, wait a minute. Why do I have a big honking wire wound resistor in here? Then I realized I think I bought it for to make a little LED tester or something. Yeah, I think I'd found a circuit online to build a little constant, or I guess a constant current LED driver, so that I could figure out how bright I wanted my LEDs before I picked a LED, the series resistor for the LEDs. So I think that's what that wire round resistor is for. I don't know why I have this sneaking suspicion that okay, well, I think there's the 5.6 k ohm I was looking for. It looks like there's only one in there. So let me check the instructions. So there's only one of those. Okay. And I found the trim potentiometer already. That should be on the table somewhere. All right, now for the ceramics. Should find some 1.1 microfarad. Yep, I think these are them. Right there. Let's see, a 10 microfarad. Electrolytic. All right, I think those are them. I bought some Nichicons, 100 microfarad. I have 100 farad. Okay, I think those are in the box. Actually, those might be in my hand, believe it or not. No, actually, hold on. 10 microfarad. Oh. Actually, I have 2 bags of 10 microfarads. I must have. And 2 bags of 0.1 microfarad ceramics. Okay. I must have ordered more thinking I was going to run out. All right, so I'm looking for the 100 microfarad capacitors. It's still bugging me where those diodes are. Because the thing is, I moved since I bought all these parts, so if the parts were not in, let's just say if I misfiled the diodes, then there's no telling what I did with them. Okay, so there's our 100 microfarad 25 volt electrolytics, and then there's the 2200 microfarads. I already had those off to the side here. Ah, yes. Okay. And then we get to some of the fun parts. We have an AN 6562 op amp. That is not it. Oh, wait a minute. Okay. This is one of the parts that was discontinued. So I have some op amps here that may be drop-in replacements. Maybe not both of them. There may be other op amps somewhere else on the board. However, I believe I did buy from UT Source some AN 6562s. And I believe that the bag of parts I bought off eBay MIDI sync. Oh, that must be an EEPROM. Ah, I bet I can figure out what version of the Zocks box the eBay seller I bought these parts from was going to build based on the label that's on that, what I think's the EEPROM chip. But I thought I saw. Yes. All right. From the eBay seller, I have 2 AN 6562s. And then I have the, there's 2 different op amps I have in that are different part numbers. I'll have to pull up their data sheets I believe at least one of them is a pin compatible op amp. However, for authenticity, because the op amp is one of the things that gives the TB-303 its characteristic sound, I want to try to use the authentic part. Now, because I do know that there is a distinct possibility that I got duped into buying counterfeit chips. How about some dip sockets? I don't know how good they are, but they are dip sockets, and they look like they might be dual wipe, so maybe they're okay. I think the op amp is an 8-pin. Oh, score. That's nice. Actually, I just noticed something. The eBay seller wrote quantity of 2 on his little bag of AN65 62s, but I spy well 3. I'm actually looking at getting another lens for my Raspberry Pi camera so I can try to zoom in even closer. So those are the chips I got from the eBay seller. I don't recognize the manufacturer mark, but I'm not saying that those aren't legit. They may very well be. I just don't recognize the manufacturer mark. They look like they were made in 2006, which could be correct. Because Adafruit was able to source the parts when they were selling those, when they were selling the Zocks box. So I think 2006 was the time frame they were selling it. Okay, so then the ones I bought 10 from UT Source because when you're not sure what you're going to get, you buy extras. I know these are going to be hard to see somewhat because they're in a plastic case, but I think you might just be able to make out they do have the same manufacturer mark. I can't really read the manufacturer date on these, but without taking them out, they do look like they're laser etched. So these may very well be new old stock from UT Source. So I may very well not have any trouble. So anyways, so there's our AN6562s, which I'm socketing because of just in case I have to swap them out. Much less interesting is our linear voltage regulator. Just a 7805. We have a 78L06, which is a 6-volt linear regulator. And we have an LM336Z reference diode. So that is all the parts we need for the power supply. Now I do need to find the diodes. So I'm going to go to a be right back while I go find a place to try to go through this box a little more intensely, somewhere where I actually have enough room to dump the box out. So stay tuned. I hope to be back with 4001 diodes in hand, or at least something that is compatible. So I will be back. Got them. There they are. I overlooked the box that I think had somewhere written on it may have Zocks box parts in it. They weren't in an anti-static bag, but I believe those are the 4N001s I am looking for. But to confirm, and because it happened to be in the same box as the diodes were in, interestingly enough, I don't know, maybe my past me thought my future me might need to double check the small printing on something in the box. Or probably when I was moving, it was just convenient. And quite honestly, I would say the convenience is way more likely of a scenario than future me being that forethoughtful. But I found my little pluggable USB microscope. So if anyone says that you need a fancy stereo microscope, you can get started with something like this. And we'll use this to confirm. The nice thing is you can use it handheld, but it comes with a little stand of some utility, which at least has markings on it so you can kind of get an idea of sizing of things. So you will hold on momentarily while I try to find a good place to plug this in. Tempting fate. All right. USB microscope is set up and ready for use. All right. So I think I am going to need to tempt fate in OBS here by changing does not support. Oh, well, I guess that's the largest size it does. All right, whatever. Okay, so it does 1600 by 1200. Anyways, it has a little light on it, and basically it has a focus. So the one catch about these, the way they work is the magnification they tell you is assuming you put the item like really close and focus in on it. But the nice thing is it does have a decent working range. So I believe, let me zoom in a little more. Oops. Oh, I didn't mean to do that. All right. So we'll do that and we will focus in. Okay, maybe that's just a little too close. Actually, let me do this. Hold on while I change strategies. I just realized in the tape reel, they're all lined up about the same direction. So what I need to actually do is take one out and focus. All right, so I was looking for the IN Okay, this is, yep. I think these work better if you can set something under it and then let it stabilize. So let's do that because I don't want to give anyone seasickness watching that really hairy video, so I'm going to not put it so close, but we'll still get a good read of it. And you can see it's an IN something or other. So it's an IN. Let me adjust the light so I can see the printing better. Oh, I think that's about as bright as it'll go. All right, so it's an IN. Oh, sorry. Kind of a little hard to get a good, but it's an IN 4001. So those are indeed the diodes I was looking for. I will let my past me know that I should do a better job of putting things in their proper place when I'm done with them. All right. We'll go back to, oh, wrong one. Yep, there we go. That's the right one. Perfect. All right. So I will hold onto this little camera in case it comes in handy somewhere else. Also, just looking to see what came with that camera. Thank you for choosing Pluggable Refurbished. 90-day warranty. That expired quite a while ago because it's been sitting in a box for a year. Write a review and follow us on social media. Oh, these are kind of cool monster drawings. Having troubles? Yeah. Those are pretty cool drawings. Instructions. I think they probably could have just said plug it in. All right, so we have all of our components. And it took quite a while to find them, which is good. All right, so the instructions do say to okay, so the instructions do implore you to test and measure all the resistors. However, I think that is because when you buy the kit, the parts may have been mixed up. So, without further ado, let's get soldering. All right, so I'm going to set all these parts off to the side, and I'm going to go in the order of the instructions. And the first step in the instruction is it tells us to attach the power socket, which snaps into the board like so. So that will actually help hold it in as we solder. And when I say as we solder, I more accurately mean while I solder and you watch. I don't expect that you will be able to reach through the YouTubes and provide a helping hand. So, I've got my flux. Got my flux pen. It's not the best flux, but it's not the worst flux. It's so flux. I've got my lead-free solder. I have a bevel tip, which is actually different than the one I was using yesterday. I have tip tinner, because I should tin, since it's a brand new tip, I am going to tin the tip. I have my Hecko, which is now powered up. I have it set to 750 degrees Fahrenheit. I do not know what that is in Celsius. And I am turning on my smoke absorber. Because smoke absorption. Pro safety tip. Unlike some of the stock footage you may have read about online, or how it would lead you to believe you hold a soldering iron, you hold it like so on the safety grip. Because this end is really hot. In fact, I can feel the heat radiating off of it. How hot? 750 degrees Fahrenheit. So now I've got the tip tinned. I'm going to use my brass whatchamacallit to kind of clean off the excess tinner. And I'm going to put that to the side. And off camera, what you can't see is I've got a soldering iron stand. So I am going to apply my no clean flux. I'm going to actually double check that it's actually applying because my safety glasses are fogged up and... Oh yes, I have a good amount of flux on the board. Possibly too much. And I am going to start with this one closest to the edge of the board, because I believe it is it's not on a ground plane. Now, honestly, this would probably have been a good time for me to pulled out a slightly bigger tip. And I may start to solder this and realize that this small chisel tip is actually, I am realizing that now. That is, I need a bigger tip. All right, so timeout, delay of penalty, false start. Yeah, I wish I'd realized that before I let the soldering iron heat up. Well, I'm not going to feel too bad, but I'm going to have to change them out again once I get this soldered on. But yeah, this conical tip is really too small to solder such a big area. I was checking the temperature of the retaining nut. It is still too warm to grab a hold of. Yes, if I had the next level up in Hakko irons, I could actually hot swap the tips. But this is the FX888D, which is still quite capable. It's just you can't grab the tip and yank it out. Still just a bit warm. Just dawned on me that on the TV, I've had this video playing the whole time. No, did not need to have a live playback for myself. I'm hoping that hasn't been causing an audio echo. But that would just be par for the course. That was maybe probably still a bit warmer than ideal. Alright, so I think for that, to solder that, I want actually, I think I do want that tip right there. So this is some sort of a chisel tip. It looks to be about the right size for these pads. All right. Try that again. I do need to tin this tip as well. While we wait for the iron to come back up to temperature, I'm going to apply more flux. I'm sure there's a point at where you have too much flux. But I don't think I'm there. All right, iron's up to temperature, so I'm going to tin the tip. I like to tin the tip of, I know they come pre-tinned, but I like to apply my own tinner on new tips. I'm not aware of anything that says you can't. So now, I should be able to do that. And I think that looks like it looks like a decent solder joint. Now this tip will come in really handy for these other two pads because I think they are on the ground plane. All right, and make sure. And I need to put some more flux on the board because it looks like I used up the flux on the first two. All right. And oh, sorry about that. All right. All right. Oh, it's a bug of some sort. Huh. Oh, you're a little bug. I don't know what you are. Yeah, just a little bug of some sort. All right. Well, as I was saying, I think that those look like decent solder joints. In fact, actually, I could. Let's see here. I just came up with a brilliant idea. This. And let's see, duplicate. And we're going to call this and let me make this easy to get to. All right, and let me add a source. This might end badly, but hopefully it will cooperate. Let me add a new source. This is going to be pluggable microscope. And there is that. I think all of the settings look good. And oh, of course, it's going to actually let me drag further. Oh, all right. So let me get rid of. Let me move that source. And fit that to screen. And might as well do that because that'll maximize the and oh, it kind of looks like it's gone all wonky, so we'll deactivate, we'll reactivate it. Oh. All right, there we go. And that is how you realize you should have added a scene for your microscope that you didn't realize you had until after you started streaming. I have another microscope, but it's bigger and sort of entangled in the microphone right now. All right, so here are the solder joints. I guess I can move the board too. So I think those look like decent solder joints. There's plenty of solder because that is a item that you're going to unplug. And this is lead-free solder, which will not be shiny. So that dull appearance is not worrying me because it will look dull. So, back to our assembly, and I just realized another benefit of doing that. Well, actually, that's not helping any. All right. Well, I will put that down below where we can get to it. So, all right, we soldered the power. Insert the power plug and measure the voltage across the jack. All right, let me, so that we can step through this, because it as you test as you go. Let me plug in the wall wart. I'm hoping I can plug it in close enough. Hold on. This, All right, now not only is the microscope entangled in my, let me turn my soldering iron off because we need to switch tips for the next step. So I might as well let that start to cool down. Yes, not only now is my stereo microscope entangled in the microphone, but it's also entangled in the wall wart. So, the instructions say to insert the power jack and measure across those two points, and we should have at least 9 volts AC. So I am on AC. Well, I guess with AC, there's really no such thing as positive and negative. So I guess I didn't have it backwards, and of course, my hand is in the way. And nothing. Okay. Well, let me check our... All right, well, let me check the... Oh. It helps to be on voltage. Okay. Yes, I would have not been able to measure current that way. So we have 11.15 volts AC, which for no load sounds correct. I mean, there's no load on the transformer at the moment, so 9 volts would be what you would get if it was loaded. With no load, it will be... That's why these instructions and why I'm measuring for... That's why it says it should be at least 10 volts, even though it's a 9 volt AC power transformer. Because all that is the transformer. Oh, that's disappointing. All right. Oh, there we go. Oh, it's probably the flux. It is no clean flux, meaning you don't have to clean it. But it says nothing about if you can take a measurement through it. So that was just some 91% isopropyl alcohol. And maybe it would behoove me to kind of clean my leads too, because there was flux residue. Now it will probably measure. There we go. Yep. It was flux. All right. Okay. The instructions do point out that you do need to power the board to test it unless it otherwise says. But it also reminds you to unplug the power before you solder. You do not want to solder it with power plugged in, or mess up something you will. All right. And And luckily, that was long enough to sling the tip out. And put the other one in. So the tips I'm using tonight are in we're in a generic Hacko, well, it's not a Hacko set, it's a clone of Hacko tips set that I bought from Amazon. Links in the description. But apparently today, Hacko USA is running a promotion for, I guess, the next, well, few hours. I think they may be on the West Coast, so you may have more time than if they're on the East Coast. But apparently, if you place any order with them, and it may be while supplies last, and you put the words thank you, THANK space YOU, and I don't know if it's case sensitive, they capitalized the T in thank and the Y in U. You put that in the special instructions field, and you get I think you get a free Hacko mug and a free Hacko cutters. The Hacko, like, side snips. These aren't the Hacko ones. These are just the ones I have laying here beside me. And that is in addition to if you would get a free gift from the value of your order. So I actually ordered some genuine Hacko tips over lunch and I got my free gift that you get to add because I had $30 in the cart. Free shipping for being over $25 and should get their anniversary thank you gift. So thought I would drop that because I decided which tips I was using this generic set to kind of get an idea of what I liked, and I kind of figured that out what I wanted. And actually, a few of the tips I wanted, there's nothing in this set that's equivalent to them. But I ordered some genuine Hacko tips, so I may do a side-by-side comparison, although honestly, I don't know. Some of them there may be a difference, and some of them there may not be. And some of it may be more you couldn't tell up front, but maybe longevity you would, if you had them long term, you might notice. The Hacko tips I've read are possibly plated better. And I could believe that. Alright, I had a diode on the table for testing. I don't know what I did with it. But anyways, so these diodes are polarized. There is a stripe on them. You can see that silver band on the one end. And on the PCB, there is also a stripe. If you notice the stripe there, and then on the other side. So you do need to make sure the stripes line up. Because these 4 diodes make up the bridge rectifier. Some AC circuits, they'll actually use a bridge rectifier chip. That's nothing more than the 4 diodes in a single package. But in this case, they're doing it the old school way with 4 diodes. And that might be because Roland did it this way. It might be that might be a part where it doesn't really matter and they did this for cost. Because really the net effect is there would be no difference one way or the other, because the bridge rectifiers in a single package they're the same thing. They're 4 diodes So, all right, we've got I got the 4 diodes in. I am going to kind of bend the leads just enough to keep them in place, but not so much that if I had to desolder one for some reason that it will cause too much trouble removing it in the future if I had to. All right, so there's our diodes. I will try to solder these without blocking your view, but that is possibly going to be a little difficult, so. All right, had trouble getting the heat applied. Honestly, this tip may be a bit smaller than I need. I may have to switch tips. Yep, all right. Okay, I'm going to switch tips. This tip is too small. All right, tip change penalty. I may swap to okay. I'm not sure what size that is, but I'm going to go with that tip there. When the iron cools down enough to pull it. I guess while we wait, I will, because you could probably see that there is a chip on the board already. It's a surface mount, and I actually reflowed it. but it's the FTDI FT232BL. It's the USB to serial adapter chip. It's the only surface mount chip in this kit. So I actually reflowed it using my reflow toaster oven. And I used a little template to apply the solder paste. So then really carefully place the chip down in place. So I've not tested the chip, but it looks like it did solder, so hopefully when I have the proper voltage to test it, I'll be able to plug it in and it will work fine. Alright, I don't think I've used this tip yet. This is a little smaller than the one that I used to put the AC jack on, so alright. Tip is tinned. I suspect my flux is dried up, so let me apply some more flux. And okay, that is weird. Alright, let me try different. Lead. Those solder joints don't look that great. Let me them up. Alright, well, let's see if these do any better. Oh, well that... Well, that looks awful. Alright. Alright, where's my tweezers? There they are. Yeah, the chip is, or the diode is... I didn't secure it well enough. It's halfway... It looks awful on the other side. Alright, well let me see if I can get the diodes on the other side soldered. They're still where I put them. Alright, I'm running into the problem that I ran into yesterday. Where I was able to get the solder flowed fine yesterday when I was soldering some easy to solder parts. Then I started soldering an IC socket, and it stopped flowing well, and that's where when I turned up the heat more than I should have. And it appears as if flux is not helping. I've tried different tips, so I've come to one conclusion. I'm glad I didn't order a full spool of that solder. Alright. Well, I need to desolder the pins on here, because that diode is just sloppy awful. But let's see here if I can't figure out where I'm going to put this. Well, actually, you know, I guess I could leave this right exactly where it is. All right. Yep, I've got a free workstation that I'm trying to find a place to put it on the desk, because it's kind of large. Need to use the desolder functionality. Alright, so there's the desolder gun. Here's the power cord. This is the point of the stream where I realize that my desk is not big enough. All right. Luckily, I plugged my Hecko in far away from my computer. Therefore, I did not fall for the trick of unplugging my computer. All right, and now I'm going to plug the rework station in and turn it on. And I'm going to realize that I need to read the directions. Because I need to turn off the hutter gun. Because I don't think I got enough power to run the hutter gun. And I don't need it. All right. All right. I think you just Oh, it seems to work pretty nice. Oh, there we go. There's how you turn the things you don't want on off. There's power buttons on it. Probably would help to put some flux on it. Might also help to read the directions, but who's got time for that? All right, well, one of these two diodes is... Oh, there we go. Yeah, that's better. They put a little more flux on that. And hopefully that will be... All right, I've got 2 of them desoldered. I still got a pin stuck in. Well, let me apply more. Actually, this might be the point where I take a soldering iron and very carefully push that pin through. Very carefully. And what better way to very carefully do that than to use your brand new tip. Oh. Okay, it would help if I read the directions. Oh, well, that might be why my desoldering gun is not working that well. Alright, it's complaining my soldering iron is open. This is weird. Ooh. There we go. That is... feels much better. I think it's... Alright, it is set to 350. I presume that is in Celsius. And I will tin the tip. And then I will find that I put the so I'll grab my new brush or brass thing, and now I'm just going to try to push this pin out. And use a little solder wick. And I'm sorry that's off screen, but in order to avoid more damage than I want to cause by having to desolder this. I'm doing this at a place where I am comfortable with it. I'm on out pin. All right. You know, that was dangerously close to my finger. So put the needle nose on one side, soldering iron on the other. Hold the board oh so carefully and apply heat. Oh, that's pretty warm. And desoldering gun. Well, if I can get this pin out, then I can continue the project. Because what I'm going to do is Okay. This. It's getting. The weird thing is the iron is getting hot, but it's like acting like it's not getting hot enough. Okay, it'll melt 10. Oh, there we go. Oh, yay. All right. The pin fell out. Let me suck the solder out of the hole and oh, yeah, let the gun get warm. All right. That rework station is not working correctly. The temperature is all over the place. Oh, the plug for the desolder gun looks like it might have been damaged, or the cable at the strain relief looks damaged on the desolder gun. It may very well indeed not be regulating temperature correctly. It also looks like the foam pad's out of place inside of it, but I don't think it was getting up to temperature. I don't think the soldering iron was either. All right, well, I guess I'm gonna fall back to solder wick. I got the pin out. It fell on the floor. I don't know where. Metal pin on the floor. It's not like I ever come down to the basement in bare feet. I actually do that all the time. I mean, what do you consider that? All that I've got pin on the floor. All right. Another tenor. Well, I appreciate anyone that is still on the stream, as you've been painfully watching me trying to fix the mistake. Well, at least I do know my Hacko is working right, even if the solder is flowing miserably awfully bad. Like, really awfully bad. This is the same solder wick that Bruce at Brankus Creations uses. It's Goot wick. And it actually does seem to work pretty good. I would ideally like to get the solder out of that hole. Solder flux on this side. Well, oh. That's lovely. I got the solder wick stuck in it. Come on. Wick the solder. Well, I guess I see that I've come up on the 3-hour mark. And while I haven't destroyed the board, I certainly am going to have trouble continuing until I can get the solder out of the hole where I had to remove the diodes because they just went in really badly. Unfortunately, I don't have one of those little manual solder suckers because I broke the last one I had, or it didn't work very well, one of the two. And my electric one that I bought and thought I wouldn't need a manual one, well, it doesn't suck, if you know what I mean. And sort of like flooding this board with solder flux and getting it all down my arm. I got one last idea. So we're gonna wait while the tip cools down. And yes, if you're wondering, that tip is still kind of pretty warm. That's why I'm not grabbing it for long. Alright, so I am probably going to do the stupidest thing yet this evening. I have this long, pointy tip that seems to have no real-world purpose. And I'm hoping it will help me get the solder out of the hole and the solder wick unstuck from the board. I'm not going to stick it in very far. I'm just going to try to stick it far enough to get this out. And this is actually a case where I may actually have to turn the iron temperature up because well, maybe not. Maybe it is. All right. Oh, all right. Oh, it is. So anyways, I'm just trying to get a precision heat to the solder. I'm increasing the temperature because I can tell the tip is long enough that I can tell that the heat is it's not 750 Fahrenheit at the tip. Because I'm using the very tip. So I'm just gonna go up, not ridiculously slow, but in more reasonable steps. Yeah, the tip is still I'll go up to 785. That still feels, using the tip tenor as a guide. I'm gonna go up to 800. Also going to apply some more flux. Because if I use all this flux pen, that'll give me the excuse I need to buy the really good flux. No, that's not doing what I want it to do. All right. Yay! I got the solder wick free. Now maybe that Well, I kind of got a little bit of the solder cleaned up. All right, I'm gonna try one more tip change. Well, actually, it'll take too long to change tips. All right, I cleaned up the pad. Yay. All right. Well, I have streamed longer than I intended to. I'm going to have to let the iron cool down again before I can change tips. So, I'd like to thank everyone that stuck around to see me get one part on the board. I'm hoping I didn't damage the board. Well, there's one way to find out, I guess. Go to continuity mode. go to now I can think mode. I mean, I think the audio settings were such that you could probably tell I had a fan running, but hopefully it wasn't too bad. All right. All right, I don't know. Let me see if I can tell from the board which of those is connected to which. I think these two are connected together. Oh, okay, we're good. I just maybe need to be careful when I solder it, but it's still continuous with what it should be. All right, so next time on Music Monday, now that I have all the components, we are going to continue soldering the power supply. I will make sure that I put all the parts together that we will need for that, so that we don't have to go hunting for them again. And I am probably going to switch to leaded solder because I cannot get this lead-free solder to flow. So I am probably going to use leaded solder because I can't keep messing up boards. So if you'd like to be notified when I attempt to continue putting this together, give me a follow on Twitch, subscribe on YouTube, maybe like the video or dislike it. Won't hurt my feelings. Maybe leave a nice comment, maybe some feedback, constructive criticism, maybe a hi, I saw your video, sorry you had trouble. Maybe something to know that someone watched this video. Because I know right now on the view metrics, I have one person watching on Twitch and seemingly I can't tell if I have 0 or 1 person on YouTube. So it'd kind of be nice to know sometime that even if you're just lurking, that hey, I lurked. Thanks for sharing, trying to build it. Because I'll tell you what, you could probably tell that I'm learning as I go sometimes, and that I am doing this totally live. Because if I had time to try it first and then build it, well, you'd probably know. Anyways, yeah, at this rate, we'll have the Zocks box built in the year 2345. Or something like that. One component, a live stream. I think next one, I think it'll go much better from here because I'll just use leaded solder and lower tip temperature. I know how it works. This is what I get for trying to use the lead-free stuff. So, anyways, I will be live again on Wednesday for, at the moment, I'm calling it Whatever Wednesday. I don't know. Maybe Whatever Wednesday may involve putting the rest of this power supply circuit together, because I really would like to know that I didn't cause too much damage on this board. So, or we'll look at Raspberry Pis. I haven't decided. Maybe if you have a preference one way or the other, if you really like Raspberry Pi, or you'd like to see the power supply circuit completed on this, drop a comment. If I see comments voting one way or the other, winner wins. And we'll say, if you're voting for Raspberry Pi, I have a Pimoroni Picade to put together. So there you go. Zoxbox power supply or Pimoroni Picade assembly. So if I get any comments, whichever one gets more votes in the comments will be what we do. Otherwise, it will be whatever I feel like right before the stream starts. So you'll have until, I think, 7:59 p.m. on Wednesday, because both items are down here in the basement. But until then, this is Justin, also known as Classically Schooled on Twitch, signing off on this not entirely successful soldering adventure. So, hope to see you next time, where it can only go up from here. See ya.